So, yeah, back on the grind, starting part C, legitimately starting it now, rather than what. So, yeah, back on the grind, starting part C, legitimately starting it. See ya. God damn it. I left my stream page open in the browser. I guess that means it's working, but I mean, I don't know. I always get kind of scared it's gonna fail by like an inception or something, or it'll just melt down the computer, which is usually what happens. It'll just overheat to that extent. But no, it's all good. We are live. Camera. I feel is a bit more kind of. It's a bit slower. It's not as sharp as it usually is. It's a bit laggier. But I don't know. It's not such a big deal. I don't think. Let's have a look at it. Mic is absolutely fine, as it always is. Yeah. It's kind of, it's okay, but it is a bit juddery, and I think I need to look into improving the lighting, I think, in the room for that to be okay. Particularly at night. I think daytime isn't so bad. Nighttime, I think, yeah, because I'm doing nighttime streams these days, just it's a bit more convenient, I guess, and I have more of the motivation to do them at night, to be honest, these days, even though I've been trying to move my sleeping back. But yeah, I could just turn the light on in the room. I have a lamp on, but I may as well turn the ceiling light on. Yeah, it should be all good. So, live, 2 minutes. Camera is working. Microphone is working. So, my stream page has a quick summary of where I am in the project, so I don't need to, thank God I don't need to explain that anymore. But I mean, basically what I'm doing is I'm still working on Raft, the distributed consensus algorithm. There's an illustration on my stream page you should definitely check out if you've never heard of Raft. And I'm implementing persistence. Well, I'm not really implementing persistence yet. What I'm actually doing with this first session is implementing an optimization that was only suggested at the point where it says about, where the project starts talking about persistence. It's like, well, in order to make it fast enough, in order for persistence to work or something, you'd better implement this optimization. And so that's what I'm going to do. Yep, it's all about the data phase, as it always is. A piece of data goes into Raft, it gets written and by everyone, then committed by everyone, and then it gets output. And so what we're interested in, to elaborate on that slightly, the data goes in, the leader picks it up and writes it, and then sends it to the followers. And all the followers also write it. And then once a majority of followers is written, the leader commits, and then the followers follow the leader's lead and commit. Followers follow the leader's lead. It's not symmetrical, it's just like blah, 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 blah. Them sentences like. Yep, and what we're interested in, where the optimization is that I'm going to be implementing today, it's about writing on how the leader sends out data for the followers to write. There's this thing called nextIndex, which is an array, and ID is an index which specifies a different server to the leader, because it's, if ID is not me, so my ID, what's in the array of IDs corresponding to myself is not important. It's just everyone else. The next index is the thing that should be sent next to in the log, which is an array of data. Next index specifies the start point of what the follower needs in order to get its log synchronized with the leader. And so you can see here, there is a condition here that is about decrementing next index, which is saying not enough of the leader's log has been sent for the follower to be able to synchronize with it. Because if you think about it, we're assuming the followers and the leader sort of keep up with each other. And so if someone goes out of sync, but then we get back in sync, it's like, okay, the follower's log is broken from a particular point onwards. And so the leader, in order to figure out where that is, it starts as if nothing happened, but then the next index keeps getting decremented on every message send because the follower is replying failure. This is false. So the follower is saying, you've not given me information I need. So our optimization is, instead of just decrementing by one and retrying, what we want is for the follower to be able to predict the success and tell the leader how much data it needs, rather than the leader just trying again after a -1. Just trying again by giving it the next piece of data, the previous one, and then the one before that, and then the one before that, until the log goes back far enough that they can be synced together. So, yep, camera, live, mic. I don't, I've had some internet dropouts lately, so I just don't really want to lose work, so I'm just checking my streaming software occasionally. Streamlabs OBS, it's used by most streamers, I think, whom I've seen. It's kind of simple, easy to use Windows streaming. With mucho bugos. Many bugs. Too many bugs, too many bugs like that. Alright, so yeah, that's it. That's what we're doing today. I don't feel like this is going to take too long, but it will require a bit of thinking. It's like a mini puzzle that needs solving. How can we not just trial and error our way by decrementing next index? How can we instead preemptively figure out what next index is on the follower side? The whole point of that is that it skips so many of these steps. And these decrements are important because it's not just decrements, it's also decrement and then retry. So on the next heartbeat, it's going to send the same information but with one more, and so it will keep sending messages for every decremented next index. It gets decremented and then it just runs the loop again. And so the optimization will stop us from. It will mean we get up to date a lot sooner, and therefore have to send a lot less data out on these append entries messages, because we immediately sync everyone up, basically. That's the kind of idea. And I mean, it's not an optimization I would necessarily have made of my own accord, but it did say do it in the Part C preamble that MIT wrote. So yeah, let's do it. Do it. Do it. So what we care about is success, because it's saying, once we get success, the log merge is pretty simple, and all we have to do is this. And these logs can get pretty big, so we're not just doing the naive solution of the follower overwrites its entire log with the leader's log, assuming, of course, that the follower should do that. But whether it should or shouldn't do that is more or less already covered by, well, whether or not it trusts the leader. But that's covered by a different code that we're not thinking about. So this is assuming, that we should react to this RPC, and the follower is saying, yes, I should sync up with the leader. Assuming that's happened, obviously his trivial solution is just copy the entire entire log of the leader and make it my own log. But that requires so much data transfer, so much overwriting. I don't think that's a good idea. Well, the thing is, if Raft goes on for like a long time and these logs get really long, then it doesn't. I don't know. I'm not convinced it's a good idea to overwrite the entire thing. I think that would probably slow it down. So I don't know. It is. I mean, it is a solution and the valid one at that. It's just I don't feel right about doing that. It's the brute force solution. Well, unless this is brute force. So this is another kind of simple algorithm for trying to do the same thing. I should point out, what is success? I mean, success is it's assigned to by the follower replying to an append entries. It's assigned to by the follower figuring out well, basically passing this condition, whereby basically what this is saying is there is an entry, the log index that the leader sent out. So the leader sends out prevlog index and prevlog term corresponding to the prevlog entry, which is the previous entry in the leader's log, the entry preceding the payload of new data that the leader sent out. And so the follower is ready to receive the new data. As you can see here, it just appends it straight onto the log once it's cut the log off at the prevlog index. And it can only do that if the entry at prevlog index, which is not sent over by the leader, but is instead referenced by the leader because the leader sends over every entry after that one, those entries have to be present in the follower's log. And the whole point is that is what success is. If they're not present, then the leader will receive a failure message and decrement next index. And so prevlog index in term decrement 1, prevlog entry is the one below, and you know the drill, you just do that again. So yeah, pretty much that. That's what this is saying. So this is saying prevlog index is a valid index in rflog, and at that index, rflog at prevlog index, the term there is the same as the term that the leader sent, which means the message is, loosely speaking, identified as being the same, because it was, given in the same index at the same term, and the term uniquely determines a leader that wrote it down. So, unless the leader's bipolar or something, but I mean, that's not, I don't think it's something I can't prove, but I can't think of a way that the leader would commit, it would write things with two separate terms. That just, pretty sure that's impossible. Although maybe it's just, I can't be bothered to exactly figure it out. But yeah, I mean, I think it's a reasonable assumption to say that doesn't happen, and that's why we have this criterion. We don't care why we have the criterion, we care that this is the criterion. So the point is, what we're trying to do is optimize to find the smallest, we're assuming that this RPC exchanges, so the follower is constantly replying fail because the leader's not sending it enough data. So we're trying to optimize to find the minimum index such that the follower succeeds. That's basically my solution here. Rather than the follower sending over the leader sending the entire log from scratch, which is going to be wasteful if the logs get long, and rather than the leader just decrementing and trying again, so moving it down one by one with its attempts to find this minimum where success is true, the follower can probably preemptively figure it out, if you see what I mean. So that's what we're going to be thinking about now. What's up? Welcome back. Have actual fans now, it's crazy. Yeah, I didn't realize, by the way, that you make chatbots. I didn't realize. Lots of different strands of AI, but I didn't realize chatbots were your thing. I just sort of popped on the stream and I don't know, messaged some random stuff, but yeah, it was kind of fun. I don't know too much about chatbot AI tech. No, I'm just happy to have fans, I guess. Well, yeah, it's nice. It's nice that what I'm doing is actually interesting. That's gratifying, I think. Because it's not that obvious that it will be. Thanks. Yeah, I like yours as well. Although I think to an extent what I've been doing is random. At times the bot sort of says something that's quite related to what I've been saying, and it's kind of interesting to see where it goes when you're conversing. At times it's a bit more random. Ah, cool. Yeah. Yeah, so just doing a little optimization at the moment. Thanks, no, thanks. I appreciate the compliment. What started out as me just wanting to teach myself distributed systems and doing it on stream for motivation, for fun, and also for learning to speak. learning to continually speak what's on my mind. I think that's good because it's actually made it easier for me to just like what I often do. I'll go to gigs in London. I do a lot of underground gigs, and I just find I feel less inhibited just talking to people afterwards. Just like talking to the musicians about what they're doing and that kind of stuff. And so I feel like this helps with that. And certainly at a job interview, it'll be great to be less inhibited. Although you don't want to be too casual at a job interview. I feel like I'm getting rejected because I seem a bit a bit casual and not hardworking. So I don't know. We'll see if I can fix up. Yeah. How to optimize success. How to find the lowest value of success that works. Well, I mean, what we're doing is we're trying to pass this condition, and I don't feel like this condition is that hard to optimize. Um, so what does the follower know? The leader is sending prevlog index and prevlog terms. So the leader is speculating on what the follower needs with its previous log entry. And so if this fails, then the follower, this condition, if this is why success is false, because this fails, then the leader can immediately know if the follower just replies with how long its log is. The leader knows that the follower cannot be willing to receive things that are beyond the length of its log. So the follower's last entry cannot be further than its log, the last thing in its log. And so if the log has really fallen behind, then that's a big step, right? That's like, okay, the leader now knows, because the follower replied with the length of its log, not to set the next index, specifying what it should send next to the follower, beyond the length of the follower's log. So I think that's optimization number one, solved. I'll be adding 13 of Hal emotions that control how Hal looks depending on mood. When Hal is mad or when I'm looking mad. Yeah, Hal is pretty chill. Cat-like thing, just kind of chill like this, I don't know, it reminds me of looking at a Vaporwave video, so yeah, emotions will be cool, for sure. Yeah, I'm glad you do get that. It's, so much of what I do is out of context, but I think this is reasonable. This is actually really the last thing I'm doing with Raft in terms of the main bit of the project, because this is an optimization that I was told to implement in Part C. And Part C is about persistence. And persistence is not really related to the rest of the algorithm. It's all about a server saving its state and then resuming its state if it crashes and restarts. So it's like save state and reload on an emulator. Whereas, because I know all about those NES emulators and whatever. And yeah, that's that. Whereas the rest of Raft is all about what the emulator is actually doing, right? So they're not that related. But the project did tell me you should do this optimization, because I think there are some final tests at the end that are like quite heavy, so it needs to be a bit faster or something. But the project literally said optimize this. I wouldn't be optimizing it otherwise unless it failed the test. So that's my first optimization. Is there anything else that I care about here? Well, the thing about why this optimization works is because it's a kind of monotone property, right? If the length of the log is greater than the previous log index, then it will be greater than the log index before that one. Or conversely, if the length of the log is further back than the prev log index, then the prev log index can continually be decreased until it's below the length of the log, because that means that there is not a case where the entry that should be being sent out, like one of the ones in the middle, works. That's a really bad way of explaining it. It's like I have a log with 10 things. I'm just going to use a quick example. I have a log with 10 things, but the leader has 10 things in its log. The follower has 5. But then it's not possible. The reason we can then set the leader to send from entry 5 is because we know that entry 6, because entry 6 is not in the log, that means that entry 7 is not in the log, that means that entry 8 is not in the log. So it's a monotone property, if you think about it as an order relation. And that doesn't apply to this. That's why I brought up that spiel. I don't think. When we're picking terms, we can't use that kind of optimization. We have to, I think, check these explicitly. But at the same time, I mean, I feel like what the leader is doing is good enough when it comes to that. I'll explain what I mean by that in a sec. Sorry, I zoned out a bit. Show you how to do this, then copy you the source. I've seen you in there. Thanks. Yeah, yeah. Well, I don't know what you want to show me exactly. So, just I guess what your project in general, how to do that kind of stuff. Because yeah, I'd be interested in learning about it simply because if you're just using one of these things, you have absolutely no idea about the technology. If you're using machine learning, for example, you have no idea in what way you're using machine learning, and so learning about that would be cool. I'd be down for learning about it. I think Raft is pretty cool. I actually had someone on my stream yesterday who sent over, the illustration of Raft, which is my like, oh, if you don't know anything about Raft, look at this first. He sent it over in my chat, and I was like, yeah, this is it. This is what you should. This is how to introduce people to Raft, because it's I don't know, a simple intuition on how Raft processes data, which is really the most important thing. But then it also talks about elections as well, so it's all good. Yes, yes. 3 weeks away. Do you mean 3 weeks away? Sick. Yeah, yeah. Let me know. Let me know. Definitely. This project, I think, Raft. I think it will be done fairly soon. I'm feeling like it's going to be done quite soon. I don't know. We'll see how it goes. But after that, yeah, I guess I have the key value server. I haven't yet decided if I'm going to stream myself doing that. Because I have to admit to myself that streaming myself doing these projects makes them take, I think, at least twice as long than they would otherwise. So I haven't decided yet if I'm going to stream the projects 3 and 4 of MIT, but I've done projects 1 and 2 will be done soon enough. The fun bit of 2 is definitely, I think, going to be the final, once I've implemented this persistence thing, the final debug where I have to pass the stress test. I think that's going to be fun. I'm kind of looking forward to that, so it's going to be cool. Candidate release of Man Like Hal. Nice, nice. Get hyped. It's a shame I'm not releasing anything. I'm just doing a toy project, coursework. But I guess sometimes you have to. Web projects, I say, don't do toy projects. Do a real thing. Like that's what I did. Because web programming's kind of easy enough to find something, a tool that you can make. But distributed systems is too large scale for a personal project like that. All right, so let's focus. That's basically it. I honestly don't think that there's anything else to optimize it. Well, wait, no. I mean, I'm not agreeing with myself. So this I can one step optimize. Obviously, all I have to do is get the follower to send back the length of the log. The earliest possible thing that could work. But then it's possible that in the follower's log, that entry has the wrong term, and then the entry before has the wrong term. But checking that, it is true that the follower could check that. But it would need to know all of the leader's terms because this is a monotone property, so it only needs to know this one number. I mean, it doesn't even need to know anything; it just sends back its own log length. But here, in order to check this, it needs to have all of the terms for the part of the log that could be conflicted. Okay, so let me not get it twisted. I mean, so okay, say we're running this algorithm and the follower fails, as in it replies fail once. That's kind of what triggers this entire system. Then it sends back the length of its log, and so the leader next tries, either decrements by one, or it actually just tries to pick the length of the log and start from there, of the follower, the length of the follower's log, whichever is smaller of those two. But then if it's going beyond that, it's like I don't know. It's like the leader needs to check the leader's term for that entry and then the entry before. So it would need to know the leader's previous entries all the way down to the bottom in order to completely optimize. So we can have a partial optimization along the lines of, oh, the leader just sends back two previous log terms or something like that, some constant. But that's just adding unnecessary complexity because, if you're thinking computational complexity terms, it's still the same complexity. You're just sending two at a time. You're making the code a lot more complicated. But there's no way of predicting in advance which one is the first one that's going to fail this term check. So I think the only optimization we should make is this. Sending back to the beginning of the log, because this is just, it's not possible to test it without the leader sending its entire log over, starting from scratch. And then we may as well, I guess, replace the entire log, which was like my brute force solution. It would save RPCs, but it wouldn't save the number of messages sent, but it wouldn't save the amount of data, because you send the entire log, that's obviously too heavy. And if we overshoot, and we didn't need to send the entire log, it's obviously inefficient as well. So I think this is why I'm trying to explain, this is why I think this is the only optimization that I'm going to make. And it's a pretty simple one, so we'll see. We won't actually know if this optimization is good enough until we do the final tests for part C, and so we're going to implement persistence before we do that. But, we'll see how it goes. So I'm just going to try to pass the earlier tests for section 2B and 2A. And hopefully save a bit of time, make them a bit faster. We'll see how it goes. I've been on this for 13 months now, no worries. Sorry, I don't know what no worries is referring to, because I went off on my explanation. And because, Twitch, I would say Twitch has a latency of about 10 to 15 seconds. And because I'm doing single monitor streaming, maybe I should get another monitor, because then I can just throw my eyes at the chat quickly while I'm speaking and not get distracted. I don't know. It doesn't matter. But yeah, 13 months. 13 months is cool. It'll be interesting to see. What a sense of completion, a sense of like, okay, I have now a candidate release after 13 months. That's going to be quite gratifying, and yeah, I wish you the best with that. It's going to be cool to see that. The fuck! I'm not going to Sofa anymore. Just don't do it. It's too commercial. Okay. Email why? I don't know. Why does this just happen randomly? I mean, I got these emails like 2 days ago. Anyway. Alright, yeah, let's just bang out that optimization. Let me just jump onto Streamlabs. Camera is working, mic is working. I'm still live. I'll just put a note in chat saying like, let's implement an optimization. Live, camera, mic. Hey, yeah, you can probably see actually if you saw a chat message appear much earlier than I said that I would post it. That's how you know about the latency. That's just a fun little thing. Alright, simple enough. Okay, so let's have a look at the sketch notes that I have for how part 2B works. Do I want the whole of... Yeah, I think 2B is sufficient. So I'm looking at append entries, these variables. So we have prevlog index, prevlog term. reply, it replies success, and that's the only thing that it replies. It does also reply term, which is, election term and some other stuff, but that stuff is strictly related to the election cycle, and so it doesn't bother me. Data cycle is where it's at. So I'm literally just going to put in last log entry here. Or even just log length. Log length is cool. Hello, random dude outside my window. Oh, it looks like he's just looking for something. Have you seen, by the way, people just use sat nav on their phones while walking now? It's quite funny. You'll see someone walking down the street and it just goes, in 10 meters, turn left. Nice. Log length. Log length is sufficient, I think. So the point is the follower is just constantly replying with the length of its log. I should say receiver for consistency. And then the leader acts accordingly, and we'll see how the leader acts in a sec. But that's pretty simple, I would say. So let's do that. Should not take too long. Save. That's log length. The thing about this is that if React is true, React is about comparing election terms, and it's basically intuitively, should the follower, which is running this function, which handles the response to receiving data from the leader via the append entries RPC, should it react at all to this RPC? Because if a leader that got replaced like years ago and then suddenly joined back in the network, that leader should be becoming a follower pretty soon. But at the same time, it might have some extant messages that are then being sent, and so this should not then react to those messages at all and do anything, because then things will mess up. The leader loses its right to leadership. And so we have this React condition that basically embodies that. So it's kind of, I've defined it here. Outcome less than or equal to 0, and the outcome is the signaling function of, in maths terms, it's the signal, what's it called? No, the sign function of my term minus the other person's term, the leader's term. And so if this is less than or equal to 0, that means the leader has term greater than or equal to mine, which means that I should pay attention to the leader. Its term exceeds mine, or is equal, which means I should listen to it. Because if its term were less than mine, that means that the leader is old and should just be ignored, basically. And so that's why everything is in this if react section, basically. Cool. So if react, if not react, then log length is going to be set to 0, which is totally cool. Log length should be set to 0 in that situation. 0, I mean, the log length is always at least 1 if it's been set, because the log always has a dummy variable in position 0. It's a 1-indexed array, and so there's like a dummy thingy in position 0. So that's fine. But if React is true, then we may as well... The thing about React being true is that we pick up the log. So if React fails, then we don't pick up the lock at all, which means the code runs faster. We only pick up the lock when we need it, i.e. this thing is actually responding, taking the reply seriously. And because we're in the log, it's easy enough for us to just say log length. That has to be capitalized, yeah, because RPC fields have to be capitalized for some unknown reason. It's in the spec or something. And it's just going to be defined as len rf.log. Easy. Okay, that's it. That's all that the log length is, and then all the leader has to do about the log length. This thing. We have this criterion here that is saying, okay, we should not decrease the next index if it's gone below. If it's at 1, basically. To be honest, I would say this should be written as greater than 1. That's idiomatically more correct, because it's saying, if this is some number bigger than 1, then we try to decrease it. So if it equals 1, nothing happens. So greater than 1. And instead of just doing rf.nextIndex, I'm going to set rf.nextIndex to... 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 a number that is in fact the minimum of the decremented number. Oh yeah, that should be at position ID. It's the minimum of that number which has just been decremented and the length of the log. You've got to be slightly careful for off by one error here. So rf dot log length. This is all contained in replies dots. No. This should all be contained in the React section. Okay, I've got to be slightly careful here. I could have just about introduced a bug here by accident if I were not careful. Live camera action. Like, yeah, I've got to be slightly careful. This isn't checking for reacts. I mean, it can't really check for reacts. I guess maybe it can, but yeah, okay. So I mean, the thing about if React is false, then the log length gets set to 0, which is not good because 0 loses a comparison to numbers bigger than it. It would be nice if we could set it to infinity, because that's signifying it's too big for us to care. But I don't want to do that. I also don't want to put in any like max possible integer or anything like that because I feel like that's a bit inelegant. I'm a mathematician, right? I don't do that shit. So instead, what's I don't know. What's the simplest way of doing this? It's like we are handling replies fail, but we don't want to set it to 0. Well, this is the thing. I mean, if, like I said, 0, the only situation in which log length is allowed to be 0 is if it's not been set. And so we just need a condition that says if the length is not 0, then... Oh, the length being 0 just means we should do nothing, doesn't it? Because this thing is really out of sync. Oh, I guess. It's kind of a matter of choice. I'm saying, if React is set to false, as in if this is an RPC that the follower should not even be reacting to. Oh, but then the leader is going to be set to be a follower anyway, so we don't actually care what happens in that situation. The only situation we care about is if React is true. Well, does that mean that nextIndex can just be set to 0? That might cause a crash, though. You want to be careful about setting nextIndex to 0. Don't do it. Lol. Lul. Okay. Yeah, sorry, I just had a bunch of thoughts go through my head. Because I just want to be careful about not implementing this in a really like nasty, buggy way. If React is false, that strictly means the outcome is positive, i.e. the follower dominates the sender, and therefore the sender is definitely failing term sync. The leader is going to be deposed as a result of that. Is that going to cause a crash? It depends. I mean, it's concurrent, so you can't really predict what's going to happen in that situation. I could put in more code that forces this to be a leader again, but no, I mean, the RPC is allowed to go on beyond this phase. It's allowed to have not replied in time. That's another thing that's slightly dangerous. Adjusting follower indices based on responses. How? Okay, let me just. This is a bit sketchier than I thought it would be. Whoops. This should be great. Yeah. I'm just gonna leave it at this kind of steady state, so I can just have a bit more of a subtle think about what's going on here. Yes, I mean, heartbeats are sent out. The leader sends out heartbeats, then it waits, checks if it's leader, and then, it calls in the heartbeats and it reads the replies variables, and you know, it says here literally implicitly times out RPC response. So you know, it's allowed to fail in this situation, even if there's a timeout, even if maybe it shouldn't be sending older data. But I mean, failing is kind of okay, I guess. But we just have to be careful that we don't code something stupid, to be honest, something that could crash. We can't make any assumptions, basically, is what I'm saying. This is allowed to fail because the RPC times out. It's allowed to fail because the follower failed the check. So the data we get back is allowed to have all sorts of bullshit in it. It's allowed to have like a log length of 0. It's allowed to have, what's the other thing that gets set? Oh yeah, just success, isn't it? So yeah, that's the thing. So success coming back as a default value of 0. I guess we should just check for that, shouldn't we? I mean, yeah. We check this. Um, if next ID is greater than 1, and then just decide what to do with next ID. By doing a bunch of clunky if statements, I guess. This isn't going to slow down the code. Realistically, just doing a few extra if statements per heartbeat, because there's only one leader that's doing that, it's not going to realistically slow down the code that much. So I don't want to be too anal about optimizing this. I'm just going to drive through with a few if statements along the lines of, well, this optimization that I've just done, let's just say we do that completely separately from the usual decrement. So I'm saying here, let me check the length of the log. So check number 1 is rf.log length, replies.log length. This is also under a lock, but replies isn't under a lock, so there is a potential race condition. On the other hand, if replies log length is 0, it defaults to 0 initially, and it gets defined before the RPCs are sent out, as you can see here. It makes a bunch of append entries reply structs, and those, in the specification of those structs, you have this log length thing which defaults to 0. So this is always possible to check for, and initially this is always true, it just might get edited later. But if it does get edited, then we run this code. If it does not get edited, then we skip this entire optimization, and so we're safe. Safe. Alright, that's cool. If replies log length is 0, then what do we do? Well, if it's not 0, that's when we do stuff. And the stuff that we do is we append entries reply has no log length method. What did I do wrong? Did I control Z my way through the entire code? And yes, the append. Oh no! Array of append entries has no log length, but append entries itself does. So I've done it wrong because I need to specify its replies at position ID. So I access the array, pull the relevant reply out, and then pick its log length. ID being the peer, the relevant peer. And if it's non-zero, that means that I do the optimization, which is it's not just if it's non-zero. There's another condition we can check for here, which is when do we care? We want it to be possible for the previous index that the leader sends. The next index that the leader sends from. That. So just this is going to be what the change that occurs to next index, right? In the case of optimization, and in the non-case of optimization, I'm going to run the original thing, which should mean the code works as similarly as possible to how it used to work. That's the reason I'm doing that. Let me just be careful with this is not, yeah. Okay, I realize this needs to be edited. I'm going to set the next index in this situation. Okay, so what's the, this check that I've been talking about this whole time? That means that the earliest possible thing that the leader can send the follower is the last entry that the follower has, that plus one, is the earliest possible position that the leader can possibly be appending from to the follower's log. As in the data the leader sends, that gets merged in the follower's log. If that plus one, even one further than that, there's no way, because prevlog index is not going to be inside the array at all. So, pretty simple. Next index should just be the next possible index in the log that does not exist yet, which is literally just this. We don't want to set next index to 0. This is why this is here, among other reasons. But also we need this to also satisfy the check that we're setting next index to be the log length. That means that the next index, for that to make sense, we are decrementing next index. That's all that's happening here. That means that next index should be strictly greater than replies log length for this to change anything. If it's the log length plus 1, then setting it to log length is the same as minusing 1, but that's not a big deal. Conceptually, yeah, the check is, the next index is strictly greater than the length of my log. Right? The next index should definitely not be strictly greater, because log length is the lowest possible index that does not exist in the log. Done. Let's just run all the tests. Really, there's really nothing more to talk about. I hope it just passes so that I don't have to worry about stuff. This is all about log stuff, so okay, I'm going to test it regardless, but I mean, the 2A stuff does not even involve logs, so it should just pass as usual. I may as well preemptively type the 2B test in. Hopefully it didn't just eat my inputs when I did that. See that? Alright, let's run the 2B test, hope that it works. Let me check Streamlabs live. Slip down the camera. Camera's all good. Mic is all good. 47 minutes live. Okay. The bit that's interesting is I think test 6. Leader backs up quickly. This is the bit that used to take like 30 seconds. No, 45 seconds. So let's see if the optimization has at all helped. Because, theoretically, I am saying it's not really possible to come up with a better optimization. Wait, no, sorry, I'm being stupid. This took that long in the first place because I remember the final pass time was about 41 seconds, 42 seconds. It was always about this amount of time. So I don't think what I've done has made the 2B tests faster, but hopefully the 2C tests are not going to fail as a result. I'm not going to try any harder to implement an optimization because I've already implemented a optimization. Don't know if it works, but I will know once I've tested the 2C test. And so just trying to keep implementing that would be too anal and a waste of time. So I'm going to get on with things and do the part of the the persistence stuff. Yeah, unfortunately this still takes as long as it used to. 18.6 seconds for a total of 41. I might possibly have made it slightly faster. I think let me run the tests maybe another 2 times because I remember what the averages used to be. It used to be that everything was between sort of 38 and 43 seconds, I think. Although, okay, I did make a change after that, but it was kind of more a stability change, but that could have made it faster, I'm not sure. But what I'm saying is I think I've possibly saved about 2 seconds or something. But I mean, there's no way that I'm going to be able to check that in any kind of statistically significant way. So, yeah, whatever. Never mind. But yeah, I mean, it looks faster to me. I was not getting 37s before. 38s. I was getting 38s, but I wasn't getting 37s. Perhaps I can make it even faster by decrementing some of the timeout variables. Certainly, once I manage to learn to do stress tests, I can do that. Yeah, oh god, test 2 has started just failing sporadically now. I'm just kind of sad about that. So, it passed 3 times in a row and then it failed. But there's nothing, I'm not going to be able to check why it's failing until I think of a way of stress testing. And I'm not going to do that until the very end of the project. So I will implement persistence first. And the reason for that is just that this works most of the time, so I don't really need to worry too much. Even if test 2 fails occasionally, it's a shame, but usually it passes, and it still passes about 90% of the time, and that's good enough for me to be happy to just move on and debug it for reliability later. I'm debugging it more for just basic functionality right now. Does it seem like it basically works? And then there's stuff that happens in some edge cases that are RNG dependent. We'll just find out about that later. But yeah, I did fail it once, so okay, you know what? I'll run the test another 2 times or so. This is 4 passes and 1 fail. I always get monk ass now looking at test 2. I'm always like, don't fail on me. It used to be that test 6, and what was the other one that kept failing? 3? Test 6 and 3, I think, failed the most often before. Nowadays, test 2 is failing the most often, and test 6 hasn't failed for a long time, which is nice. But you never know. Test 6 is, just by the sheer length of time, and whatever this number is, it's quite big. That means it's probably, susceptible to failure. Yeah, I'm averaging 40 seconds now. I'm pretty sure I'm about 2 seconds faster than I used to be. Whoops. Is camera working? Mic? So yeah, pretty soon, just after a little bit more testing, I'm going to move straight on to the next bit. What was the next bit again? The next bit that I'm doing is figuring out where in the code it makes sense to save state. And after that, I'm going to implement the saving of state. And after that, we just do all the tests and see what happens. If I'm fast enough, I might be able to do all that in one day. Alright, I'm done testing this shit. So basically, out of 7 tests, it passed all of them. All the tests but 7 times. No, but 2 7 times, and test 2 passed 6 times out of 7. All the others passed 7 times out of 7. Alright, I'm calling myself finished, okay? I'm not going to do anything more. That's an optimization that I implemented. It seems to be working. As in, nothing is failing. Yeah, cool. Yep, so... Session 224, nextIndex optimization is what this is. So just commit that. May as well do a git push. No reason why not, while I'm sort of sorting myself out and waiting to start the next thing. Okay. Pretty simple. I'm gonna now jump onto Streamlabs and edit my Sesh text. No, my camera text, sorry. What am I doing? Well, the answer to that is I am now still doing Q2C. Sorry, I just shouted. Where to persist. I always click this, it always screws up. Does that still fit? Bloody Streamlabs. Yeah, it looks pretty good. I made the text slightly smaller, but it looks pretty good to me. Inserting persistence points, and it's about 55 minutes in. 5500 when I posted that, so you know what I'm saying. Know what I'm saying? Camera, mic. Camera, mic. Alright, let's go. Week one. Week one. um, so, okay, let's just do a quick jump on. So, because I'm doing this without sketch notes and scrap notes, because I think it's easy enough for me to be able to YOLO it, basically. So I'm just using MIT's thingy and looking at, their project page and just looking at what they say about how to do this. So this is basically it, right? This is the thing that I really need to do, and I've decided I'm going to do this first before I um, implement these. I don't know why I'm doing this bit before I'm doing this bit, but it doesn't. It just kind of felt natural. So I guess because it just builds on code I already have. You now need to determine at what points in the Raft protocol your servers are required to persist their state. Maybe implementing this will give me a better idea of when I should make calls to persist. But then again, this is literally just save the state variables and bring them back. And it says here, the paper's figure 2, i.e. the blueprint, cockpit on the stream, bottom right corner, the blueprint, that's what this is, it's in the academic paper, figure 2. I have a copy up on my Twitch page. Mentions which state should be persistent. I should definitely read that first, because then I know what I'm trying to persist. So I can optimize when I call persist. That's easy. There's already a call to loading from the save state, so I just need to figure out where to save state by calling persist. Once you've done this, you should pass the remaining tests. Do this first, obviously, but cool. Yep, that's fine. So let's do that then. Raft extended paper jumps up. Blueprint my way through life. Alright, let's try to set the window size. This Notting Hill Carnival thing is just still there. Looking for friends to go to Notting Hill Carnival with. We'll see if anyone comes through. It's good fun though. I recommend it to people. Just a bit of a party, a bit of a street rave. Alright, so, well, it literally says, okay, volatile state and persistent state, so, yeah, easy. Volatile state literally just gets rebuilt, and persistent state gets, this is the thing. Okay, question. If a server crashes, it should reload as follower. Okay, this seems obvious, right? There's no reason that should not happen. So let's do that. Well, yeah, I mean, when the server reloads after it's crashed, it always runs the make function, which has the initialization code that sets it to follower. So all signs point towards it starting out as follower. What that means is that the leader state is going to be empty. Volatile state on all servers, this is an interesting one. So we're starting with a brand new follower, because commit index and last applied get set to 0, which means that, through communication, my code made no assumption about previous commit indices and last applied on the part of the follower, so even if the follower is totally green, totally fresh, everything is 0. Even if that happens, initialize to 0 increases monotonically, the new leader, whatever it is just going to be able to update it, and so it makes sense that these are volatile. This is what's persistent. Okay, so the log should be persistent because if there's a ton of data, the leader should not have to send all of the data back. Makes sense. Current term and voted for, why should those be persistent? Well, because, I don't know. Part of me says, why wouldn't you just set these to 0? Because then when RPCs start to happen, when RPCs start to happen, the term will be synced up and the thing will become a follower if it wasn't already a follower, which it was. So I don't know why current term and voted for should be persisted. I guess, well, voted for depends on current term. So if current term is persisted, then voted for is persisted, and vice versa. Those two are tied together. So it's just, my question is, why is current term something that should be persisted? And I guess the answer is along the lines of, if everything crashes, then we need to be able to determine what the term is, or else all of our work up until that point is kind of lost, because we can't figure out what the term is. We can't go back and read from logs if nobody can ascertain what the terms actually are. Because the terms in the log, and the log is the only thing that would otherwise be persisted if we don't persist term. The terms in the log, those always are a result of, they derive from the terms that whatever the leader that committed it or wrote it or handled it, received it, really. Whatever the leader's term was, that is then set, that is what the terms in the log inherit that. But never does it go the other way around, that something sets its term based on what's in the log. And so, in order to not violate that assumption, but in order to be able to keep hold of what terms are, we should persist term, okay? QED. Because then, even if term escalates, if we've persisted it, recently enough, then we will lose all of the stable data that happened after. But that's fine, because will we? No, but if the log has stuff that has a newer term in it, then that's a good point. We won't lose that stuff, because term is always, the thing that has a higher term dominates, even if it's the log. Because if we do log comparisons, then log comparisons. All right, hold that thought. I'm just gonna reset my butt because I'm getting butt pain from sitting down in that position. So I'm just gonna do what I usually do, which is pull up my